Today, Maths for Real is about changing the size of an object.
It's about making an object bigger.
Or smaller. Mathematically, we're talking about a type of transformation called enlargement. Katie, can you hear me up there?
Just about. You do know that big is beautiful, don't you?
Yeah, but good things come in small packages too, you know.
Check something for me. Does my bum look big?
Yeah, it does actually. To be an enlargement, the new shape and the original shape must be similar. Like these two cups. One is a perfect replica of the other. Their proportions are the same. It's just that this one is a lot bigger.
Smile, Jamie. Very nice. Photographs start off as a small image, but you can enlarge them to whatever size you want. How tall are you?
1.82 m, but why do you want to know?
You'll find out later.
With that one measurement, I can get a specialist printer to transform my digital image of Jamie into two much bigger cardboard cutouts.
Jamie, looking a bit flat today? Thought you'd like these. Look at this. This is a life-size version of you, exactly the same height. If you like that, you'll like this one even more. This is twice as tall, twice as wide, in fact, twice as big in every direction.
I think you forgot twice as good looking. Anyway, being twice as big means this image has been enlarged by a scale factor of 2. And you end up with this beautiful guy here.
The scale factor of an enlargement is a ratio. It's the length of any side in the new enlarged image divided by the corresponding length in the original image. Advertisers often go large to catch your attention.
They use larger-than-life images on billboards to make sure you notice them. And there's no way you could miss this poster for the Harry Potter film. Now that is what I call an enlargement.
On the side of a building in Leeds, this is one of the tallest advertising spaces in the UK. The poster is an impressive 17 metres wide and an awesome 50 metres high.
Harry's head is 6 metres wide, which will give you some idea of just how big it is. From the size of the original design, we can work out the scale factor for the poster enlargement. To calculate this, I need to choose a length on the new enlarged image and divide it by the corresponding length on the original. Let's take the height of the poster. We know that it's 50 metres high. If I measured the original, that's 27 centimetres. Now, a scale factor is a ratio, so the measurements need to be in the same units for the calculation. Let's take metres. The poster is 50 metres high, and the height of the original is 27 centimetres, which is 0.27 metres. So the scale factor is 50 divided by 0.27. My calculator. 50 divided by 0.27, which gives 185.1851851. And that, to the nearest whole number, is 185. Here's one for you. The scale factor is 185. The word Harry on the original is 4.9 centimetres wide. So how wide is the word Harry on the poster?
The sort of shapes that you'd be expected to enlarge are normally drawn on a grid. The grid makes it easier to see the dimensions.
When you're asked to draw an enlargement, there are usually two pieces of information that you're given.
1,
the scale factor of the enlargement,
and 2,
the centre of enlargement.
Now, we're going to enlarge this shape by a scale factor of 3, and the centre of enlargement is going to be this point here, C.
The first thing to do is draw a line from the centre of enlargement through one of the corner points on the original shape. Measure the distance from the centre of enlargement to the corner point. 28 inches. Next, multiply this number by the scale factor, which is 3. 28 multiplied by 3 is 84. and measure this new distance from the centre point along the line. And mark it.
You can check you've got it right, because from the centre, it's 2 squares up and 2 squares across to this point on the original shape. Now, if the scale factor is 3 from the centre, it's 6 squares up and 6 squares across to the corresponding point on the new shape. And it is.
Very good. Now all you've got to do is exactly the same thing for all of the corner points on the original shape.
Finally, join up the new points in the correct order to form the enlargement. With a scale factor of 3, each side on the new image is 3 times longer than the original.
Now, so far, we've only been dealing with enlargements with a scale factor greater than 1. And they always produce a new enlarged image that is bigger than the original. But believe it or not, it's a strange maths fact that an enlargement can also be smaller than the original. Like this mini-mini. This is a scaled-down version of the real thing here. Now, it's smaller than the original, but mathematically speaking, it's still called an enlargement. If I measure a certain length on the mini-mini, then measure the corresponding length on the real mini, I can work out the scale factor. So, from door to door, the mini-mini is 8 centimetres, and the real mini is 144 centimetres. The scale factor is the new enlarged length, 8, divided by the original length, 144. In its simplest form, that fraction is the same as 1/18. So the mini-mini is 18 times smaller than the real mini. So that's 1/18 the size in every direction. And the key thing to remember is, if the new enlarged image is smaller than the original, then the scale factor is between 1 and 0. I'm on the trail for a special scaled-down version of the Statue of Liberty. And apparently, I'll need one of these. Thank you. Because it's so small, it fits inside the eye of a needle. In fact, here at Impossible Micro World in Bath are the world's smallest sculptures. They're so small, you need a microscope or a magnifying glass just to see them. Now, Willard, you're responsible for these, what are going to be described as absolutely amazing, like, micro sculptures. What are they made of?
Specks of wood dust. Some of them are carved from flakes of gold. You know, little specks of gold which I've scraped off my wristwatch. Some of them are made from human hairs.
What tools can you use to sort of carve out these small sculptures?
I use microscopic slivers of diamond, which is like a little blade which is glued onto a pin.
So what's the smallest one you've ever sculpted?
The smallest one of them all, I would say, Charlie Chaplin in the middle of a watch cog.
Wow. So I have a question for you. What's the scale factor of a 1mm Statue of Liberty if the real thing is 46 metres high?
If you're asked to enlarge a shape by a scale factor which is between 0 and 1, here's how to do it.
We're going to enlarge this shape by a scale factor of 1/4, and the centre of enlargement is going to be this point here, C.
The first thing you've got to do is draw a line from the centre of enlargement through one of the corner points on the original shape. Measure the distance from the centre of enlargement to this corner point, which is 88 inches. Next, multiply this number by the scale factor, which is 1/4. 88 multiplied by 1/4 is 22. And mark out this new distance from the centre along the line.
And once again, we can check we've got it right, because from the centre of enlargement, it's 8 squares up and 4 squares across to this point on the original shape. The scale factor is 1/4, so from the centre of enlargement over here, 1/4 of 8 is 2, and 1/4 of 4 is 1. And that's right, that's the new point on the corresponding image.
Now all you have to do is exactly the same thing for all of the other corner points on the original shape.
And finally, join up the new points to get the new enlarged image. A scale factor which is between 0 and 1 reduces the image in size and positions it towards the centre of enlargement.
It's that part of the programme when we both tackle the same maths question, but only one answer will be right.
The other will contain a deliberate mistake that you've got to spot. So watch carefully to decide, are you going to tick it or trash it?
Describe the enlargement that transforms shape A onto shape B.
Pens at the ready? Let's go!
Describe the enlargement that transforms shape A onto shape B. Describing the enlargement means I have to work out the scale factor and the centre of enlargement. Now, to find out the scale factor, I used this ratio, new length over the corresponding original length. Now, the new length I chose, this one here, is 1, and the corresponding original length is 2. So the scale factor is 1/2, which is the same as 1/2. Now, to work out the centre of enlargement, I drew straight lines from each point on the enlargement through the origin, like that. So 0, 0 is the centre.
To find the scale factor, I also used this ratio, new length over the corresponding original length. The new length I chose was this one here, which is 2, and the corresponding original length is this one here, and that's 4. So the scale factor is 2/4, which is the same as 1/2. To work out the centre of enlargement, I drew straight lines through the matching points on the original shape and the new shape. The point where the lines cross is here at 0, 2, and that is the centre of enlargement.
So who's working slick enough to get the tick, and who's going to crash out with the trash?
Is Jamie right with a scale factor of 1/2 and a centre 0, 0?
Or is Katie right with a scale factor of 1/2 and a centre 0, 2? Now, it doesn't happen often, but it was me that made the deliberate mistake to try and catch you out. I got the scale factor right, but I just assumed the centre of enlargement was going to be the origin here. Now, it doesn't have to be. Remember, to find the centre, you need to draw lines through the matching point on each shape, like Katie did.
Always draw 3 lines if you can. 2 lines give you the point you want, and the third line acts as a check.
Isn't 3 lines a song?